Hello again everyone, welcome back to ptet.chemistry channel. So in this tutorial video, I'll go through this topical test for atomic structure. So this is actually a topical test for Chem 5070. So this is Chem 5070. This is the pure chemistry component for people in the science stream, and this is similar to any pure chemistry that you have taken in Singapore, for example, with a different subject code for the Cambridge exam, of course, and it will be similar to a pure chemistry component of a IGCSE extended chemistry or core chemistry, or even the GCSE chemistry that students in the UK would be accustomed to. All right. So let's get started with this first question. So these are multiple choice questions. So an atom of element X is represented by this format of an atom being shown as such here. So you have the proton number at the bottom and you have the nucleon number on top. So even though your periodic table showed them the other way around, but this is the way we always represent an atom, or rather an isotope of an atom. So the number at the bottom is what you call proton number, and the number on top is what you call the nucleon number, also known as mass number. Okay, and the bottom is also known as proton number essentially. Okay, so which statement about an atom X is correct? So you're looking for a correct statement, yeah? So we know that the number of protons, if I set up this table very quickly, protons, electrons, and neutrons, there are 3 protons because the proton number is 3. And this is an atom, meaning there is no charge. There is no overall charge. That is because the number of electrons must be equal to the number of protons. Because there is no charge in an atom, so the charges of a proton must be balanced out by the charges of electrons, and that's only possible if you have equal number of protons and electrons in an atom which has no charge. The number of neutrons is going to be obtained by subtracting the proton number from the mass number, or what you call the nucleon number. So 7 minus 3, there's 4 neutrons. Okay. So looking at option A and B is to do with the group number, so group 3 and group 4, and the only way you can tell the group number is if you try and get the electronic configuration. This is element number 3 with 3 outer shell, with 3 electrons, so the electronic configuration will be 2, 8, sorry, not 2, 8, 2, 1, because 2 plus 1 will give you 3 electrons, so 2 electrons in the first shell, and 1 electrons in the second shell. So meaning to say, the number of shell tells you the period, so it's going to be in period 2 and is in group 1. So group 3, group 7 is actually incorrect because it's got 1 outer shell electrons in the second shell. The total number of protons and electrons, so proton is 3, electron is 3, 3 plus 3 is 6, so that is actually correct. But let me go through D and I'll tell you why it is wrong. Protons and neutrons, together they are called nucleons. So nucleons are defined as the number of protons and neutrons in the nucleus of an atom. And that is the nucleon number. So the nucleon number is 7. As I said, mass number and nucleon number is 7. Therefore, it's not 10, it's 7. Question 2. We have this diagram that shows the possible path of the subatomic particles in an electric field. So your electric field have a plus and negative terminal. These are electric field. Your electrons are negatively charged. Your neutrons have no charge. And this is correct because when you have no charge, you will not be deflected. You will not be attracted towards any of the plus or the minus. So 2 is definitely correct. Protons is positively charged. If proton is positively charged, it will be attracted towards negative. It will not be attracted towards positive because positive will repel. This is the charge of the proton. This is the electric field. So the proton should be deflected downward as it gets attracted to negative. So 3 is definitely wrong. And electrons are negatively charged. It will be attracted towards the positive electric field. So 1 is correct. 1 and 2 are correct. 3 is wrong. Okay, we're looking for correct. Number 3, you have this radioactive isotope, radioactive meaning unstable nucleus. And we have a compound containing the phosphide ion. So the question is not really on phosphorus atom, but it's on the phosphite ion, because what is the composition of the phosphite ion? So read question carefully. Yeah. So looking at the formula, this is a proton, electrons, and neutrons counting. The proton number is the identity of the element. It doesn't change whether you're an atom or whether you're an ion. You're still the same element. The proton number is therefore still the same. It's 15. So looking at proton number 15, it tells us that C and D are definitely wrong. If you were thinking about the answer being C and D, you should have crossed it out by looking at the number of protons to begin with. So the options there are to try and confuse people who don't know what proton number is, as well as how to read representation or formula of this kind, where we always have the proton number as the identity of the element at the bottom when we write expression for an atom or for an isotope of a particular atom in this particular form, and not like how your periodic table will have shown it. All right. So this is the widely accepted international convention. Electrons is not going to be equal because you are not an atom, you are an ion. So it's an ion, it's a negative ion. A negative ion is called an anion. That's because we have the number of electrons more than number of protons. So you have gained electrons, you have gained 3 electrons, that's why you are 3 minus, you have 3 extra negative charge compared to the proton. 3 extra negative charge compared to the proton, 3 minus, gain 3 electrons. Neutron, the mass number or the nuclear number minus the proton number. So 32 minus 15 will give you 17. So 17 neutron is there, and it has 18 electrons. Okay. It all comes down to, are you able to interpret representation of the formula in this form? Okay. Or if I give you this table, are you able to write down the formula as such? Okay, so going forward and going backward, you should be able to read the information, whether from the table and get this, or from this and get the value in the table. Question 4 is something similar. So it tells you that Y 3 minus has electrons. There are 18 electrons. And the mass number is also the nucleon number. All right. So from the electrons, I should get the number of proton first. Okay. If I have an atom, I will have 18 electrons. But I have a 3 minus charge. The reason I have a 3 minus charge is because I have gained 3 extra electrons. So this is 3 extra electrons than protons. Okay. So that means the number of proton in reality is 18 minus 3. I will have 3 extra electron than proton. That's why I have a 3 minus charge. Okay, so the number of proton is 15. And because I have the number of proton and I have the nucleon number, which is equal to proton number plus neutron number. So my number of neutron is going to be nucleon number minus the proton number. So that's 31 minus 15. And that will give me 16 there. So looking at the table, I will have 15 protons and I'll have 16 neutrons. So it's a tricky question in the sense that a lot of students either will have gotten 21 because they thought the plus is a plus, but you always have to think you get anion because you get extra electron. You have gained electrons from the protons. If you have an atom, you will have 15 electrons. But you have 18 electrons because you have gained 3 extra electrons that give you the additional negative charge, that give you the anionic species. Anions are negative ions. Question 5. Which statement about both the chlorine atoms and the chloride ions? So these are two different things, atoms versus ion. Atom would have same number of protons and electrons because they are no overall charge. But ions have charges because the number of proton and electrons are not equal. Chlorine atom will be chlorine. Chlorine ion will be Cl minus. So first of all, the number of electrons are definitely different, okay? So chlorine versus chloride. What is the same and what is different, okay? So different number of electrons. From here to here, you have gained in electrons, so you have more electron than proton. You have equal number of proton and electrons, so you have different number of electrons. Chemically identical is impossible because different number of electrons. If you have different number of electrons, that means you have different number of valence electrons, meaning outermost shell electrons. Then how can you be chemically identical? All right. So chlorine will be 1 electron short of a noble gas configuration, but Cl- has the same electronic configuration as as argon. Okay, so it will have a noble gas configuration and it will be a stable enough ions. All right. There are isotopes of chlorine. They are not exactly isotopes of chlorine because isotopes are defined as isotopes are defined as atoms of the same element with the same number of protons but different number of neutrons, and we are not given the mass number. We are not told that they are the mass number, and also that this is an ion, whereas isotopes are atoms of the same element, not an ion. Okay, so this is an ion, these are not atom. Isotopes are atoms of the same element. They have the same number of protons, they are still the same element, and both of them are still chlorine, and that is why option C is actually correct, because both of them are chlorine. Therefore, they have the same number of protons. They have the same physical property is going to be incorrect, because physical properties, well, they are not exactly the same substance now, is it? They are not isotopes, and therefore they are not the same substance. So since they are not isotope, they are not the same substance, they do not have the same physical properties. Number 6, you have a radioactive isotope of carbon, has more nucleons. Nucleon is number of proton plus the number of neutrons. So you have to write out in full in a structured paper. Yeah? It's only because in an MCQ I can do this, and also because I'm doing a tutorial so I can do this. But in a real exam, in a structured paper, you have to write the number of proton in full and the number of neutrons in the nucleus of an atom. And this is compared to carbon-12. This is called carbon-12, all right? How many protons, neutrons, and electrons could there be in this radioactive isotope? So you need to be careful and read the question. This radioactive isotope has more nucleons than this, all right? So this is the nucleon number. That is carbon-6, well, carbon-12, sorry. So you have protons, neutrons, electrons. Proton will be 6 because this is proton number 6, and this is an atom, so the number of electron will be equal to the number of proton. It's also 6. The number of neutron is the mass number minus the proton number, or we can say the nucleon number minus the proton number, because nucleon number is also known as mass number. So that is for this isotope. But then we are talking about radioactive isotope. So which one is the radioactive isotope then? The radioactive isotope is still carbon, and therefore if it is still carbon, you still have 6 proton, okay, because it's still the same element. And isotopes are atoms of the same element, so they are atoms. If you have 6 proton, you must also have 6 electrons, because we are talking about atoms. So no overall charge. If no overall charge, that means the number of protons must equal to the number of neutrons. But then we see that it has more nucleon, okay, so more nucleon. So meaning to say this must be greater than 6. So we're looking at 6 protons and we're looking at 6 electrons, so C and D are out. 6 neutron is incorrect because that would be carbon-12. 6 plus 6 give you carbon-12, and that is not the radioactive isotope. The radioactive isotope has more nucleons, so it's got to be more than 12. So here 6 plus 8 is 14, so we are looking at option B and not option A. And a lot of students will put down option A because if you didn't read the question carefully, you should have circled, underline, or whatever with the question, is what I've tried to do in my tutorials all the time and explain in classes as well. So if you still refuse to work to this method, if you refuse to believe in this idea of actually seeing what you're doing, then you will have problems going forward with any kind of MCQ or structured questions. No matter whether you're with me or not, you won't be learning anything new at all, okay? Question 7. So you have symbols for 2 ions. They are shown here. So here you have an ion called a fluoride ion, and this is called a sodium ion. So sodium ion doesn't have a specific name, it's still just sodium ion. So which statement is correct? So all of these involve counting the number of protons or electrons. If I were you, I would very quickly set up my proton, electrons and neutrons counting, but I can see that none of these, oh actually one of them is neutron, so I do still have to work out the number of neutrons as well. Protons must be 9 and 11 because these are the proton number, 9 and 11. Electrons is the tricky one. These are ion, negative charge ion, because you have gained an electron. You have gained 1 electron because this is minus 1 charge. You have lost 1 electron because it's plus 1 charge. So here is going to be 9 plus 1. You gotta have 10. Here's 11 minus 1 is going to be 10. You have 1 more electron than proton. That's why you're negative charge, because you have gained electrons to form an ion, which is negative ion. You have lost 1 electrons to form a positive ion. That's why this is called a cation, because you have 1 more proton than electron. You have lost 1 electron. That's why you have a plus 1 charge. The number of neutron there is going to be the mass number or the nuclear number minus the proton number. So that gives you that, and that gives you that. So which statement is correct? The fluoride ion contains more electrons than the sodium ion is incorrect. Both have 10 electrons. The sodium ion contains more neutrons than the fluoride ion. That is incorrect. Both have 10 neutrons, as I have shown you in the calculation. The two ions have the same number of electrons as each other. That is correct. Both 10 electrons. And if I just very quickly go through the last one, it cannot be. Fluorine is not sodium because, different element. Different element means different number of protons. Same number of protons means it's the same element. Okay, because proton number is the identity of the element. Question 8. Which statement about this particle is true? If I just very quickly show you the protons, electrons and neutrons table. This is element number 8, 9, 10, 11 and 12. If you think about the electron, this has gained 2 electrons, this has gained 1 electron. This hasn't gained anything, so it's still an atom. So an atom is the easy bit. So 8 plus 2 because you gain 2 electrons. 9 plus 1 because you gain 1 electron. That's why you have a minus 1 charge. 1 more electrons than proton. Negative charge ion or anions is when you gain electrons. So 8 plus 2 because 2 minus because you have 2 extra electrons than proton. Here is going to be 11 minus 1 because it's a plus charge. So you have lost the electron. You have lost electron from the atom. Now you have 1 extra protons than electrons. You have a plus 1. When you talk about plus 2 charge, the atom has lost 2 electrons and you have got 10 electrons there. So I don't have information about their mass number apart from the one given in the periodic table, which is actually the average mass of the isotopes, blah 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 blah. There's a fixed definition that you have to know as required by your syllabus or your curriculum, okay? But what I can see really is they have the same number of electrons, contains the same number of electrons. That is definitely correct. All of them have the same electronic configuration as neon, which is a stable electronic configuration for a noble gas. And all of them have 10 electrons, therefore all of them will be the configuration of 2,8. You can check for the rest, but I mean, contain more electrons than proton is actually not correct because you have some negative charge ions where you have, you have more electrons than protons here, but here you have more protons than electrons. That's why you are positively charged, okay? Question 9 is something that is quite new in the O-level syllabus, at least for the 2023 syllabus. You are expected to know this thing which used to be in the AS level, which is first year of A-level chemistry. Now it has moved to O-level, and in the syllabus it says you are expected to calculate relative atomic mass. So here it is, to calculate relative atomic mass of this sample based on the relative abundance given. So this is for zinc. Zinc has 3 isotopes, zinc 64, zinc 66 and zinc 67. This is 40% if you read the graph correctly. This is 30%, 30%. 40 plus 30 plus 30 is going to give you 100%. So that's the overall sum of the percentage abundance. I multiply the mass, which is 64, multiply by the percentage, 64 times 40. And then I add them up with the other multiplied abundance and the mass. So the other mass is 66 times 30 plus 67 times 30. So it really does not matter whether you do abundance times this or this times this, because 64 times 40 is the same as 40 times 64. So it really does not matter which order you do them in, okay? And then I will divide by the sum of the percentage abundance, which was 100%, okay? So pop that into your calculator. So 64 times 40 plus 66 times 30 plus 67 times 30. So it's 6550, and at the bottom is 100. And if you can pop that into a calculator, or you can see the maths itself, it's going to give you 65.5, which, you know, this value is actually given in the periodic table. But with this kind of calculation question, you can never ever rely straight on a periodic table. You got to try and work it out yourself, because especially in a structured paper, if you just give the answer from the periodic table, I can assure you 0 marks straight away, because in a theory paper it will be calculate, which means it's not state. Stating means you just get straight from the periodic table. Calculate means you have to show your working, how you get there. All right, so these are the working involved. Question 10. An element X has two isotopes, so they are atoms of the same element with the same number of protons but different number of neutrons. So you can see the mass number is different. That means the nucleon number is different. Since the proton number is the same, nucleon number is different, so you must have different number of neutrons. All right, so it doesn't matter what the proton number is, okay, but they are atoms of the same element. If they are atoms of the same element, they will have same proton number. If you have the same proton number, that means A and B are out, because it's talking about different number of protons, okay? If you have the same proton number and these are atoms, so for atoms, the number of proton must be equal to the number of electrons, because overall no charge. The atoms have no charge, so the number of electrons must be equal to the number of protons. And this one, it says 3 more electrons, and that is incorrect. So D must be correct, no more electrons, but it definitely has 3 more protons, because, you know, 238 versus 235, but the same proton number, whatever number that is, 238 is bigger than 235 by 3 more neutrons. So this is one of those questions where some weaker students, I know it, you will just go straight to periodic table and you will try and find the mass number 238 and 235, and that's defeating the purpose of reading the question and interpreting information like this. Okay, so sometimes from question itself, you don't just go straight to periodic table. You got to think through what exactly they're asking you, and think through your concept instead of just recalling what you have memorized. So that's the main difference between a Cambridge O-level exam and a lower secondary exam where things were different. Okay, so they expect you to think a lot, at least for the Cambridge level, yeah, for your O-level and beyond, including A-level as well. Question 11. In which option do the 3 particles, each one, have the same number of electrons? Well, this is down group 7. When you think about down the group, they all have different number of electrons. Okay, you can count them, but it will just be a waste of time. It's just more about thinking through what is going on. If you think about it, chloride will have the configuration of argon, and then Br minus would have the configuration of krypton, and then the other one will have the configuration of xenon. And you can tell that, you know, going down the group, it just doesn't make sense for them to have the same number of electrons. All right, I can tell you the same thing again for this one. This one is going down the group again, going down group 1. So lithium will have the configuration of helium, Na plus will have configuration of neon, and this will have the configuration of argon. And clearly they do not have the same electronic configuration, yeah? Okay. What else can I say? This is group 1 and group 2. Okay, so you can think about K plus and Ca2 plus, this will have the same configuration as argon. Okay, because when potassium lose one electron, it will have the same number of electrons as argon. Same thing with calcium 2 plus, element 20. When it lose 2 electrons, it will have 18 electrons, which is the same electron count for argon, just by looking at a periodic table. Bromine, however, bromine is at the end of that period, and if you gain 1 electrons, you will have the configuration of krypton. So krypton is not the same as argon, so that cannot be the answer, which means the answer must be B, because if fluoride gain 1 electron, it's going to look like neon. If sodium is in the third period, but when you lose 1 electrons, then all you have would be 10 electrons, which will be the same electronic configuration as neon, because you lost the 1 electron in the third shell. Now your outermost shell become the second shell, which are completely filled, just like neon. Okay. Question 18. Have I quickly moved to question 18? That should have been question 12, I believe. That should have been question 12 actually. Anyway, so which graph shows the number of electrons in the outer shell of an atom? So outer shell is also known as valence shell of an atom, plotted against the proton number for the first 10 elements. So for the first 10 elements, you will have hydrogen, helium, so you have 1, and then you have 2, and then lithium you have 2, 1, beryllium you have 2, 2, what else, boron you have 2, 3, and then what else, carbon you have 2, 4, nitrogen is 2, 5, oxygen is 2, 6, fluorine is 2, 7, and then neon is, I don't want that, neon is going to be 2, 8. What do we want? We want the number of electrons in the outermost shell. So what are we looking at? We are looking at number of electrons in the outermost shell. Number of electrons in the outermost shell. So read the question. Number of electrons in the outermost shell is what I have highlighted here. 1 and 2. So it doesn't just go up. It goes up and then it goes down. So we are not looking at A. We are definitely not looking at B, because it keep on going up. In fact, you don't even need to do this if you know what I'm talking about, but I've just done this very quickly to make you see what is going on. And the only reason I was able to do this very quickly is because I know my periodic table, at least for the first 20 elements. I know them in order, the first period, the second period, and the third period, up until calcium. Yeah. So we know it will go up, but it will not go to 0. 0 is impossible. There is no element with 0 electron in the outermost shell. See, all of this is bigger than 0, sorry. So just by looking at this, I know that is wrong already. Nothing, no element with 0 valence electrons, meaning no element with 0 electron in the outermost shell. If that was question 12, this must be question 13, and this must be question 14. So hydrogen can form both H plus ion and H minus ions. So looking at H plus and H minus, if this is the proton number, so we are looking at proton, which should be 1 and 1. And in terms of the electron, because this is a H plus, so it's a cation, so you have lost the electron, so it's got 0 electrons. And this is H minus, you have gained 1 electrons, that means you have 2 electrons. So none of this question is about neutrons, so I don't need to worry about neutrons at all. Okay, so sometimes go back to the options and think about stuff before you actually waste time doing things that you don't really need to do. An H plus ion has more protons than an H minus is impossible, because it's the same element. If you have the same element, which is hydrogen, how can you have different proton number? Alright, H plus has no electrons. That is correct. H minus has 1 more electrons than an H plus. Well, H minus has 2 more electrons than a H plus. So 1 is incorrect. It's got 2 more electrons than a H plus, which has no electron at all. D must also be incorrect, since we already worked out B is the correct answer. H minus is formed when hydrogen atom gains an electrons, not loses an electrons. Because you become a minus because you have more electrons than proton, you have gained in electrons. That's why you have a negative charge. Okay, you have an anion. So it all comes down to reading question as well as the wording. Question 14. So these are atoms of copper. copper 64, that's how we pronounce it, copper 64 and zinc 65. These are different elements. If they have different element, they cannot have the same proton number, okay, because they are different elements, and different element mean different proton number. If I look at nucleon number, which is to do with number of protons plus number of neutrons, but you can also think about that as mass number because there's another name for it, and you know that that is the nucleon number. So 64 is not the same as 65, so A is out. You're looking for same, so 64 is not the same as 65, A is out. Number of electrons, okay, so if I look at copper, 64, 29 copper has 29 proton, and we're looking at the atom meaning no overall charge. If you have no overall charge, because, well, you think about it being atom, no overall charge, so therefore 29 electrons. How about 65, 30 zinc? You would have 30 proton, therefore 30 electrons. 29 electrons versus 30 electrons, definitely not number of electrons. Without even counting them, you know the number of neutrons must be the correct answer, which of course you can work it out. 64 minus 29 for copper, so what is that? 5, okay, 5, 6, 5, 5, 2, that's 35 neutrons. That is for copper. And then 65 minus 30 is going to be 35 neutron. No, hang on, what have I done wrong? I have done something wrong. Oh yeah, no, that's correct because I've just said that C is the correct answer, and they are the same number of neutrons there. This is for the copper 64, this is for zinc 65. Both of them have 35 neutrons. Next question is actually 15, which means that's the last question of the multiple choice bit. So this is again another question of working out the relative atomic mass. Here you're also given relative abundance, but unlike the previous question, this is relative abundance and this is not percentage abundance. So the relative abundance here is 1 and here is 4. So 1 plus 4 is not 100% because it's not always in percentage abundance. Sometimes it's the ratio of the percentage that can give you things like 1 and 4 here. So if you think about percentage, this is 20% and this is 80%, but the ratio of 20 is to 80 is 1 is to 4. The question doesn't really matter whether they give you percentage abundance or relative abundance. The idea is the same, okay? The abundance times the mass number. So these are elements which are unknown. So this is element with mass number 10 and another isotope of it is mass number 11. So mass number times the relative abundance, which is 1. Use bracket. I always like to use bracket because I am naturally careless. You must be very talented in maths not to make a mistake at all, because I always make mistakes, so I tend to use bracket because I don't trust myself that much. All right, 11 times 4, okay, and then I close it with a big bracket because there's the numerator, there's the top bit, and then I divide it not by 100 because I don't have percentage here, but I divide by the sum of the abundances. In this case is 1 plus 4 because I've used 1, I've used 4, and there's no other isotope, so it's 1 plus 4. Again, I use bracket. So 10 times 1 is 10, 11 times 4 is 44, 44 plus 10 is 54. 54 divided by 5, you can do this on your calculator easily. There will be 5 10 is 50, so 10.8. Okay, so they'll give you 10.8. If I'm not mistaken, this should be boron. Okay, this is very close to 10.8 or 11 as shown in your predict table. This element is actually boron, but there's not much that give away the information that is actually boron, and it does not matter because this question is not identifying the element, it's calculating the relative atomic mass. So we've come to the end of that multiple choice component, and this is the start of this section B, which are from the structured components of the past year papers. That's pretty much like how your topical test questions are mostly where I get it from. Yeah, okay, so it's to practice is to practice getting used to how Cambridge will ask questions. But of course, you don't go away and try every single past year papers just to do well in the test, because if you have what it takes, it shouldn't matter how the questions are being asked, because they do change year after year. But as long as your knowledge is there and you know how to apply them, and you are willing to apply your knowledge to new situations, then you will ultimately get the results you want, and probably even better. All right. So each particle can be used once, more than once, or not at all. So you got to read the question, yeah? And you got to choose from the particles shown below. Which particle has only 20 protons? So we are looking at proton number equal to 20. So there shouldn't be a lot of it because it's unique to the element. So we're looking for proton number 20, and this is the only one. So I've got to write it exactly as such, like that. There's no other element with proton number 20. Which particle has a nucleon number 35? Nucleon number is the mass number. So when written out in such a representation or expression, the mass number is the one on top, okay, unlike the one on your periodic table. 35. So I'm looking for the number on top, which is 35. Well, there is one. I wonder if there's another one. Nope, that's the only one. So 35, 17. 35, 17, and it's chlorine. So this is chlorine 35, this is calcium 39. Which particle has an electronic structure of 288? 288 means first shell 2 electrons, second shell add electrons, third shell add electrons. So 2 plus 8 is 10, plus 8 is 18. So this is 18 electrons. All right, 18 electrons altogether. 18 electrons altogether, 18 electrons altogether. So if I'm looking for 18 electrons altogether, I'm looking for a proton which is close to 18, but not necessarily exactly 18, because I can have ions, all right? So 18 electron is actually the configuration for, what is that in the periodic table? Argon, okay? So you can look for an argon exactly, or you can look for ions that either gain electrons to become configuration for argon, or they either gain electron or lose electrons in order to gain the configuration for argon, all right? So in the periodic table, you will have argon, and then after argon, then it will fill all the way to sodium, potassium, and then calcium. And then before argon, you would have chlorine and group 16, sulfur, etc., etc. Okay, so they are in the same period 3, and then it goes to period 4. So I can have this. This is a chloride ion. You gain 1 electrons, and you will have 18 electrons. Neon is only 10 electrons in the outermost shell. Oxygen will give me 10. This is 11. This is not an ion. This is not an ion. And it seems like my only answer will be chlorine, well, chloride, because it's a negative ion of chlorine. So 37, 17, and Cl minus. 37, 17, Cl minus. It's very important that you write everything according to what you see. Which particle is an atom? Atom meaning not charged, okay? So you're not looking at an ion. 10 neutrons in its nucleus. 10 neutrons, not 10 nucleons, but 10 neutrons, all right? So we're not looking at ion, we are not looking at ion, okay? So 79 minus 35 is not 10, I can tell you. 39 minus 20 is not going to be 10, it's in fact 19. 35 minus 17 is going to be 18. 37 minus 17 is going to be 20. So you can do this on your calculator very quickly. Or you can think about 64 minus 29 is not going to be 10. Alright, it's such a big number. 23 minus 11 is also not 10. In fact, it's 12 because 3 minus 1 is 2. So how can it be 0 at the end? I think we got the answer. 20, which is the mass number, minus the atomic number, which is the proton number. There's 10 neutron. 18, well, I don't care about ions because they want atoms. 17 minus 8 is going to give me 9, which is not 10. So it's 20, 10 neon. 20, 10 neon. For this next question, I would have mentioned in class when I went through the idea of periodic table. You would have the group 1 and group 2, and then the group 3 all the way to group 8. But there's also that block in between. It's called the transition element block. And as you know, the transition element block, out of all of these elements, only one of them belongs there. That is 60. There's copper, which is in the transition element block. Okay, so 6429 copper. 6429 copper, which is Cu. Question 2, this is completing the table. So they tell you the particle, where you need to think about, is it an atom, is it a cation, positive charge, or is it an anion, which is negative charge? And we got to write the mass number on top, not at the bottom, because these are the internationally accepted convention. So they decided not to show the 17, which is the proton number at the bottom. So we got to maintain the format as what we see in the rest of the question. So because this is an atom, so for an atom, the number of proton equal to number of electrons, because an atom is not charged. All right, atom is not charged. Atom has no overall charge. Since the number of proton is 17, this is also 17. Here, if I want to know, is it an ion or is it an atom? I look at the proton number 17. I look at the electrons equal. So therefore, it's an atom. If I think about it, I would have 20 neutrons plus 17. So the nucleon number would be 17 plus 20, which is 37. This is the identity. The identity of the element is the proton number. They are the same. So this is chlorine 37. Okay, chlorine because it's the same element. 37 because the nucleon number is different. These two are isotopes. Potassium 39, so it's got 19 protons. It's the 19th element in the periodic table. And the mass number is 39, so 39 minus 19 is 20. And there are 18 electrons there because it's a plus 1, so you have lost 1 electron from the atom. 19 minus 1 give you 18. This is an anion. It's a negatively charged ion. It's a minus 1 ion, so you have 1 extra. You have gained 1 extra electron. So your total number of electrons is 36 now, but in the atom, it would have been 35. So it should be 36 minus 1, which is 35, because the atom would have gained 1 electrons to form the minus 1 anion. Now you have 1 extra electrons than this, therefore you have a minus 1 charge, okay? 35 plus 44 give you 79. There's another way you can get this. 79 minus 44. You can also get it that way, yeah? 79 minus 44, you will get 35 as well, which is your number of protons. Or you can look at the electrons and they will give you the same answer as well, okay? Or for that, whichever one, both of them give you 35. So next one is a bromine 81. It's an atom. Element number 35, number of neutrons, 81 minus 35, which is 7 minus 3 is 4, there is 46, okay? So same number of proton electrons because it's an atom with no overall charge. Next bit is an element 37. So if you have a look at the periodic table, so look for proton number 37. Proton number 37, rubidium, RB, there's rubidium, but that's not enough because all of these, they show the mass number. So I need to work out the mass number, which is the nucleon number, which is equal to the mass number, which is 37 plus 48, whichever one you call it. I'm just repeating them because, you know, a lot of you will have remember one, not the other one, but they are exactly the same thing. And examiners like to, use the two terms interchangeably. Okay, 8 plus 7 is 15 plus 1, so there's 85. So there's rubidium 85, and everything has been accounted for. No, not yet. Look at 37 and look at 36. So it doesn't have equal number of protons and electrons. You have 1 more proton than electrons because you have lost an electron. Okay, therefore you have a plus 1. Okay, so you gotta read all the information and make sure you don't leave anything behind. okay? And it's not an easy 6 marks. It can be easy if you know what you're doing, but you know, humans are naturally careless. I am naturally careless. So that's why I have to go through the idea one by one and not thinking that, oh, easy. Okay, it is easy if you know what you're doing and if you are careful, if you check your work, all right? What is meant by the term isotopes? So these are fixed definitions that you really have got to score, but not just because you memorize it, but because you actually understand the actual definition that you use throughout your MCQ as well as in your theory paper. Atoms of the same element with the same proton number. So they are same elements, so they have the same proton number. But what is different? But different number of neutrons. Okay, so the number of neutrons in the nucleus is different. Identify 2 atoms. So they want atoms, they don't want ions. Okay, so you need to read the question carefully. Not ions. And they are isotopes of the same element. Well, definitely not the bromine, because this is an atom, this is an ion. This ion and ion, and they are not even the same element. So we're looking at chlorine 35 and chlorine 37. They are one of your most important case study. They give you the relative atomic mass 35.5, because you have 75% of this and 25% of this. 3:1 ratio. The average mass is much closer to chlorine. In fact, it's not 36, it's 35.5. Question 3 is about filling in these blank spaces on this thing called relative charges. Relative charge, relative mass means they are not the actual mass, but it's the ratio of the mass. So electron itself is very light, but electron is also so much lighter than neutrons and protons. Protons and neutrons have the same mass. That's why the relative ratio, the relative mass is 1:1. The mass of an electron is so much lighter. It's typically accepted to be 1/140. But if you write down 1/2000, which some books and some notes and some teachers will have taught this, it would have been equally correct as well. This is a gross approximation. This is more exact, but you know, sometimes it's a lot easier to remember one number than the other. But I would highly encourage you to remember this instead of just this. But both of these will give you a very small number. It's around 2000 times lighter compared to neutrons and protons. So protons have a +1 charge. Electron has a -1 charge. Well, relative charge, not the actual charge. Neutron has no charge. That's why neutrons are not deflected when it passes through electric field. When it passes through electric field, electrons being negatively charged, it would be deflected. It will be pointing. So it will be moving towards the positive electric field. This being positively charged, it will be attracted and moving towards the negative electric field. Okay. So this table shows some information about 6 particles. We are looking at particle A. We want the nucleon number. Nucleon number is also the mass number, which is to do with the number of protons plus the number of neutrons. So particle A, the number of proton is 37, the neutron is 48. So I add them up together. I will get 5, 7, 8. I'll get 85 nucleons. Explain why B is a negative ion. Negative ion is called an anion. So look at the number of protons and look at the number of electrons. Okay, so particle B has 53 protons and 54 electrons. So there is one more electrons than proton. Electrons are negatively charged. Therefore, there is a net -1 charge, i.e. a negative ion. Okay, negative ion because you have a negative charge, and there's a net -1 charge because you have one more electrons than protons, and simply that is just using the data from the table for particle B, 1 extra electrons than the protons. Which 2 atoms are, again, they are looking for atoms, isotopes of the same element. Okay, same element. You see these are the same element because same proton number. Same proton number means same element. But we are looking for different number of neutrons. So these are different number of neutrons. So C and D are not isotopes because same number of protons, same number of neutrons. But D and E, same number of protons, different number of neutrons. So D and E are what we are looking for. D and E are what we are looking for. All right. Explain your answer. So both D and E have same number of protons. Have same number of protons. If it were me, I would just use the table. 92 protons. Okay, 92 protons, but different number of neutrons. Okay, so 143 versus 146. So you'll probably get 1 mark for these and 1 mark for explaining basically what is an isotope. What is isotope? Well, what are isotopes, I guess, if I want to be grammatically correct. And did the previous question ask you to define isotope? Okay, so this is how Cambridge questions usually like. Sometimes they'll ask you to define isotope. Sometimes they'll ask you which one is isotope. Explain why they're isotope. Something are isotopes because of the definition of isotope, which is what we are doing. But we are doing it in the context of the example, which is what I have done in the context of the example based on the data in the table given. All right. Question 4, these structured questions. So this is the last question, I think, of this test paper. So these are electronic configurations, and as you could see, there's only the first shell being occupied, and there are 2 electrons, and there are 3 shells being occupied. So when you think about period, this is 1 shell. This is period 1, 2, and 3. It fills up to period 3. This is 1, 2, and 3. This is period 2. This is period 2. And when I look at group, I can tell it by looking at the number of outermost shell electrons. This one has 2 outermost shell electrons, but this is a very special one because this is the first shell. It's got 2 electrons. It's actually group 8 is actually the electronic configuration for helium. This is a special one because it's the first shell. Even though it's 2 electrons, it's not group 2 because you will need a bit of common sense. You will know element number 2 is helium. All right. So this one is filled up to the 3rd shell, and there's only 1 and 2. So there's 1 and there's 2. Okay, that's not a good idea. I use a different color ink. 1. No, that's not a good idea either. Maybe there's a good idea. Okay, 1 and 2. So there's group 2, and then here there's just group 1, and here you have 1, 2, 3, 4, 5, 6. So it's group 6. And here you have 1, 2, 3, 4, 5, 6, 7, 8. So this is group 8 very clearly because now you're in the 2nd shell. You can head up to 8 electrons, and group 8 has 8 outer shell electrons except for helium, which has 2 outer shell electrons. Which electronic configuration? So you just need to represent them A, B, C, D, or E, where you can use them more than once or not at all. A sodium atom. Okay, Sodium is in period 3 and group 1. If you look at your periodic table, you will see it's in the 3rd period and group 1. Period 3 and group 1, so we are looking at C. An atom with a proton number of 12. Atom means uncharged. Uncharged means number of proton equal to number of electrons. Therefore, 12 electrons. If you have 12 electrons, you have 2 electrons in the first shell, 8 electrons in the second shell. 2 plus 8 is 10, so you can still have 2. So we're looking at period 3, group 2. Period 3, group 2. Period 3, group 2 is this, so it's B. An atom of a noble gas meaning group 8, used to fill balloons. This is definitely helium. So if you have been to a party with helium balloons, they always say helium balloons. Okay, that is because it's a noble gas that is used to fill balloons, all right? An atom which forms, okay, so be careful. This is an atom of a noble gas. This is an atom which forms, all right? A noble gas configuration when it gain 2 electrons. Gaining electrons, therefore, we are looking at group 6. Oops, sorry, 6, not group 7. Group 6 has 6 valence electrons, therefore, like to gain 2 electrons to get to group 8, which has 8 electrons in the outer shell. So we're looking at group 6. Group 6, which the only one which is group 6 will be D, with 6 outer shell electrons. This is the last question of this topical test on atomic structure. In fact, this is probably the hardest one for you guys, and it's not very generous as well. So it's being put towards the end of the test to see how good you are by the time you reach here. There's a lot of things to consider here, especially this overall charge. All right, this is 0 because this is atom, but this is ion. Okay, so you need to be very careful. So looking at your periodic table, boron, the atomic number is also known as proton number. So number of proton will be 5. Nucleon number is also known as mass number. So it's another name that you need to get familiarized with. So that's 10 minus 5, which is 5. So essentially nuclear number minus the number of protons give you the number of neutrons. This is an atom because there's no charge. So number of electrons equal to number of protons. So that's 5. 1 row for 1 marks. Okay. Nitrogen. I don't know the nucleon number yet, but I need to look at the proton number, which is equal to the atomic number. It's element number 7, so the number of proton is 7. If I have 7 proton, but I have 10 electrons, look at this, I have 10 electrons, okay? I have 7 proton, but I have 10 electrons. That means I have 3 extra electron, okay? So this is an ion, very clearly, okay? Because I have more electrons than the number of protons. The nucleon number depends on the protons plus the neutron. 7 plus 8, which is 15. Okay. Next bit, if I look at atomic number 82 or proton number 82, look for element 82. Where is element 82? 82 is lead, which is LEAD. You are looking for this symbol PB, but again, if you write down PB, you are not reading the question name, and this is the symbol. So be very careful. Are you being asked for name or are you being asked for symbol? Right? Number of neutrons, mass number minus the number of protons. So 208 minus 82, that give me 126. You could write down 126 straight away. I just want to show you the working, yeah. So you have 82 protons, but you have 80 electrons. So you have more proton than electrons. You have 2 more protons than electrons. That means the atom have lost electron. The atom has lost electron. It has lost 2 electrons. That's why it has a +2 charge. You have 2 extra proton than electrons. Okay. Next bit, you have this element number 3, which is basically just lithium. Again, not the symbol, but the name. All right, the name. Number of neutrons is 3. 3 plus the proton number. 3 plus 3 is 6. And atomic number is the proton number. And we know the charge. The charge is +1, is an ion. So I have lost an electron from the atom. The atom would have equal number of electrons as the proton. There will be 3, but I have lost 1 electron. So 3 minus 1, I will have 2 electrons. Now I have 1 extra proton than electrons. That's why it's a +1 charge, right? So this is the end of this topical test on atomic structure for the Chemistry 5070 syllabus, which will be equivalent to any pure chemistry course, whether you're in Singapore or the UK doing the IGCSE or GCSE pure chemistry curriculum. And yeah, I mean, I hope that was useful. And if that was useful, don't forget to subscribe and share the channel widely with friends, your various chat group, your social network of contacts, your relative or whoever else you know who will benefit from my channel, which caters to 14 to 18 years old chemistry curriculum. not just for the British curriculum, but for any 14 to 18 years old chemistry learners globally as well. So thank you for watching, and I'll see you in the next video. So rest out any questions you have, whether in class if you're from my class, or whether through the YouTube comments if you've got any, or if you've got queries on my solution. I can make mistakes here and there, so do let me know if you spot any mistakes. I've tried to work as slowly as I can so that to avoid unavoidable mistakes. But you know, mistakes are common when you don't check your work. In a real exam, you always have to check your work. Okay, so thank you for watching again.